No, we're not. Depends on how far you guys go in this one. All right. Now, quiet down. Stop talking. Thank you. Now, we're going through exercise 1F again. I'm just quickly showing you a few things that I noticed that normally comes up in exam. And for those who are up to date, you probably would have got up to these questions. If you haven't, then at least I'm giving you a tip. That way you know how to approach it, because they normally come up in exam sacks. Those are the kind of questions that students struggle with, because if you only do the first part and you don't do the last parts, these are the ones that will come up and you're sort of like stumped. And I'll show you where you're stumped and why you get stumped on it as well. So there's a few questions. After that, I want to jump into 1G if I can about power functions and get you to really think. And then we've got a double session on Thursday where I'll really get you to sort of apply what you're thinking and see what I'm seeing with power functions. Because you learnt so far linear, you've learnt quadratic, you've learnt cubic, you might have touched on quartics, but essentially with the first three, you should know everything now. So you should know x to the power of half, x to the power of a third, x to the power of 7 on 2. All of that you should be able to do if you understand power functions, which is what my aim is to get you to understand in our double session and applications as well on Thursday. So, touching a bit on 1F today, and if I could also touch a bit on 1G. Okay, so here we go. Now, let's recap. We had three things that you had to remember for inverse functions. That's what the examiners will test you on. Can you name me one of them? Let's go with Zainab.
Sorry?
Name me one thing about inverse function. There are three parts to it. What are the three things you must remember?
Domain of f equals to range of inverse f.
Very good. The domain, so three things. We've got one of them was domain of f is equal to the range of the inverse and vice versa, right? Range of f is equal to the domain of the inverse. What was the second property? Let's go with Juliet.
One-to-one function. It needs to be a one-to-one function for the inverse function to exist.
Very good. It has to be a one-to-one function in order to have an inverse function. And the key word is function. Just out of curiosity, anyone remember, how do I test if it is a function or not? What kind of test do I do, Ivana? Good. Vertical line test to test if it's a function. And then how do I test if it's a one-to-one or not? Daniel. How do I test if it's a one-to-one function or not? So what next? Let's go with Jichang. Good, horizontal line test. Vertical will tell you if it's a function or not, because it could be a relation or just a function. So if it crosses once, it's a function. Horizontal line test will test if it's a one-to-one, because if it crosses once, then it's only 1x to 1y. That's only crossed once. Whereas if it crosses twice, what that implies is that you've got two x values for the 1y value. That's what the horizontal line is representing. It's a 1y value, and if it crosses twice, then that means you've got two x values. So that's a many to one. Right? So what we just said here, if you want to know if it's a one-to-one function, you're doing two tests straight away. You're doing a vertical line test. Is it a function? Great. Then you're saying, well, just because it's a function doesn't mean it has an inverse function. Horizontal line test will show you if it has an inverse function or not. So that's number two. And this is what they normally test you on the exam. So if you're getting stumped already, write that somewhere because that's what you need to know. Right? Number three, we had domain switches. We had one-to-one function in order to have an inverse. What was property number three? Because that's going to lead into the next slide where you're going to, it shows in the exams whether you really understand it or not. What's the third property?
Is there a reflection in the y-axis?
Very good. Reflection in y equals x. And this one, I really want you to write that somewhere in your exercise book, highlight, because in the next slide, when I'm talking about intersections of your two functions, this will play a massive role in whether you're going to be able to do it or you're not going to be able to do it. It's a typical exam question, exam 2 or exam 1, whether you understand that concept, reflection in the y equals x line. I'm going to try to explain that, yeah? But these are your 3 points. Now, let's do question 14. Why did I choose question 14 and 15? You can do 15, I'll do 14, right? 14, why did I choose this one? I'll show you why. If we just ignore this section, this B section, we'll get back to that later on, okay? Because you need these 3 properties to answer B. But let's have a look at the graph. G of x, I'm going to call it y for now. Y equals to x squared plus 4x. What kind of function do I have? Quadratic. Okay, so it's a quadratic graph, parabola shape. I've got a quadratic graph. Now, remember what we did yesterday when we were doing inverses? We said if it reflects in the y equals x, technically the y now equals to x and x equals to y. Now I'll show you why this is a problem. I'll show you. If I say y equals x, now you've got x equals 2. Instead of x, I now have y because that's the reflection. Why is this a problem? There are 2 y's. So every other problem that you've done so far, up until question 14 and 15, you only get 1 y and you just reverse everything. You know, you normally say take away 4 and then it goes on there and then you divide 3 and you get your inverse function because you want to make y the subject. But then here, you've got an issue because if you pull the minus 4y across, you still have a y here. If you divide both sides by y, you still would have a y on each side. So there's a problem. What is the technique? And there's only one technique that you learned since year 9 and 10 to reduce 2 y variables down to 1. What is it?
Complete the square.
Complete the square. So of all the quadratic techniques, there's only one. You've got 2 y's or 2 x values. The only way that you can have one variable is completing the square because then it becomes factorized. It factorizes into have only 1 x and you can undo it.
I was going to say
Sorry? You could use the quadratic formula as well. Yes. And that's what I mean. So there's a lot of ways. So quadratic formula to solve for a double y and at times that would way it's just that the you know with the square root and everything, some students may find that tricky. Yeah. So there are a lot of ways to do that, and those are the 2: quadratic formula or completing the square. In this case here, I would say complete the square, and you get the 2 set of functions. You can look at the properties there. But here, completing the square is key. Whoops. Whoa. Let me just write that again. You've got y squared plus 4y. 4y equals x. Now, when you're completing the square, how do you complete the square again? Anyone remember? How do you complete the square again?
You'll be 4 on 2 squared minus 4 on 2 squared.
Very good. Remember, completing the square just means you don't have a perfect square at the moment. If this is your equation, if it was a perfect squared, it means that when you factorize it, you'll get 2 brackets and then it's squared, right? Right now, you've got y squared plus 4y. There's no constant. If you factorize this, it's only a factor of y. So we're now going to try to add in a term, which is the constant term, so that this can be factorized perfectly. So for those who don't understand what a perfect square is something like this. Okay, that's a square. Perfect square would mean that if I said this is 3, that must be 3. If I asked you for the error, you would say it's 3 times 3. True? Now, going back to what you did in year 8, year 9, it's the same concept. Perfect square would mean if I had x minus 1 as one side, the other one would be x minus 1. If we did applications last year with quadratics, what they would have asked you is areas and volumes and whatnot. In our case, it's area. Then if I asked you to find the area, you would have said it's x minus 1 times x minus 1, which conveniently was factorized into x minus 1 squared. That is perfect square. True? And then you read your perfect squared or completing the square form, you read, well, that's to the right by 1. If there's a plus something on the outside, it goes up by 1 or down by 1. That's what this was, right? Then our problem right now is if I expand that, I've got x squared minus 2x plus 1. That has a constant term. This one doesn't. So what I'm saying is, what should that constant term be such that I get a perfect square? So the question is, what are the brackets should be? And one of the patterns we learned last year was that if you half the b term, so that's negative 2, if you half it and then square it, that will tell you what that last term should be. So negative 2 divided by 2, negative 1. Negative 1 squared gives you the last term. So if that's true, if that gives you this last term, by halving the b term and squaring it, well then you can do the same for this one. If that's a plus 4, you want to know what the last constant term should be. Half the b term, which is 4, 4 divided by 2 is 2. And then you square that, that tells me this last term needs to be a plus 4. But remember, mathematics, you can't just add in a +4 out of nowhere. So what did you have to do? -4. If you put in something, take it away, then technically I haven't got anything. Right? So that's what they were doing. They're saying, well, if I add a 4 and then a -4, technically I haven't changed the equation. So the question is, why did I do that? It's because now I know this y squared plus 4y plus 4 is a perfect square. That's why I can factorize it now. Now I can say, all right, well, let's factorize this. And I know that factorizes down to y squared. Someone quickly do that in their head. Or at least, yeah, y plus 2. And then what you'll find is the y plus 2 was just half of the 4. Half of the 4 is actually that number there. Same thing here, half of -2 was that -1 in the brackets. And over time, you don't have to actually factorize it yourself. You just know it's half of this b term will be there. You can try expand it. Square the y gives you the y squared. Double the 2 and then times the y gives you 4y. And then square the 2 gives you 4.
How about -4?
Yeah, good. It's still there. The -4 is still there. That's what completing square is. And that's beautiful. Whoops. That's beautiful now because I've got just the y term and you're back to square 1. How do you remove the -4? Add 4 on both sides. How do you remove the square? Square root both sides. And then how do you remove the +2? -2 on both sides. This is the technique to reduce 2 y variables down to 1. Or you could do what Alfie said, do the quadratic formula, and that would have gave you the answer on the left-hand side as well. Same drill. Okay? But here we go. I'm just going to rub this section off. So my tip was for you to do this step here. Don't get stumped. That's just to complete the square. That's what I wanted you to take out of it.
Oh, the question isn't finished yet.
Okay, complete the square. No, because we still haven't solved for y as a function. So I'm going to try to delete all of this. All right, here we go. So our final answer, add the 4 on both sides. I get x plus 4 is equal to, these cancel out, y plus 2 all squared. Square root both sides. You get y plus 2 is equal to, these two cancel out, root of x plus 4. Whoops. And then minus both sides by 2, you get -2. What have I done wrong? What have I done wrong? Plus or minus. But at the same time, which one is it then? Okay, good. And that's the thing we have to work out. That b to infinity is your domain of your function. So that means that it's the range of your inverse. If this is my inverse equation, that domain matters. That's why you can see in the second exams, they're going to do that on purpose. Your job is not, one, most students will just do a plus. Most likely examiners will switch this around and go -infinity up into b, and you assume that it's a positive root, you'll get it wrong. So be careful when you're doing these. The first property, which you told me just then, domain of f is the range of the inverse. That's what you have to check.
So it can be minus or plus?
Well, in this case, because the domain is b to infinity, it's the positive side. So that means the domain is positive. That means the range of the inverse needs to be positive. So it can't be negative. Okay?
And to find b...
Very good. So how do we find b now? So now we've done the hard yards. That was the algebra part. Let's use our theory now. How do we find b? What does it need to be? So think about it. I've got a quadratic. It's a many-to-one function, but we already said part 2, it needs to be a 1-to-1 for an inverse function to exist. So quadratic's not a 1-to-1. And it says from b to infinity. So what would I have to do with the quadratic to make it a 1-to-1? Good. Remove one of the sides. It could be from the center. So my job is, in your quadratic graph, somewhere, I need either this side onwards, so where the turning point is, all the way to the right, that's a 1-to-1. Or from the turning point all the way to the negative, that's a 1-to-1. But clearly, they want me to take the positive side. So if you want to find b, what are you really finding?
Turning point.
Turning point. It's the x quarter of the turning point. Anyone remember the quick way of finding a turning point? Negative b over 2a. That was from derivatives. Okay? So negative b over 2a. Yep.
With doing that, don't you find the domain of the quadratic?
Yep, the domain of the quadratic. No, you're right. Because that is the domain of the quadratic.
Yeah, But then, how would you find the domain of
Well, it doesn't ask you to, does it? No, it doesn't. But if you wanted to, just find the range of that graph, and that range will be the domain of the inverse. Yeah. So if you sketch this graph after you find what B is, then you know how to find the range. Yeah. Okay, so here, find, you've got x squared plus 4x. You can use what Jack said, x equals negative b on 2a. That will tell you the x coordinate of your turning point. Our b is 4, so negative 4 over 2a, which is 1, negative 2. So that tells me at x equals to negative 2, that's where my turning point is. Okay, that's where the x turning point is. And that's all I cared about. This is negative 2.
I did that, and I don't know why, but I found the same turning point, like point.
From here, yeah? Yeah, that's correct.
But it's the reflected lesson, isn't it?
No, this is still the y, that's still there. I haven't actually, this is the correct equation for the inverse. So that's the inverse. This is the process of moving them. Yeah? But yeah, that x minus, if I return it all and that was an x, then that would have told you that the turning point is at negative 2. Yeah. Okay. All right. Very good. That's 14. You can try 15. Same drill. What I wanted you to take were two things. Listening. Shh. Quiet. You can talk at lunch. You can talk whatever, but don't talk during my class. Here we go. You got complete the square. That's what I wanted you to take out. If you have two unknown variables that you need to combine them, it's likely if it's going to be a SAC or an exam, your job is just to complete the square. So don't forget that technique. Okay, they come up often. And number two, check the domain. So the first property you told me, domain of f is the range of the inverse. This is important. When you square root, there's a plus and a minus, and it does matter which one it is, dependent on the domain. So there's only two things I taught there. Okay, complete the square, check the domain of f is the range of the inverse. If you don't check that, you lose that mark, and that carries on. Yeah, because they're all consequential marks. If you're getting this wrong, that means when they ask you to sketch, your sketching of the graph is wrong too. Okay, so you're losing marks as you're going by. So make sure to get those steps checked in. And it's only 3 properties, yeah? Just 3. So make sure to really understand those 3. Yep.
You have to find the domain because it's asking for the inverse x. So do you have to find, like, do you have to write the function to get that mark?
Yes. And how would you find the domain of the inverse? How do you find the domain of the inverse again? What would you do?
Find the range of the
Yeah, sketch it and find the range of the function. That's why I said every methods question, sketch it, visualize the problem. This is a quadratic graph, turning points at negative 2, and we know we want just the positive side. So find out what the y value is. If it's at negative 2, sub negative 2 in. Negative 2 in, 4 take away.
It's minus 4.
8 is negative 4. So it's negative 4 to infinity.
Did you just use that equation that you did, but just swap the x and y, the blue one?
This one?
Yeah.
Yeah, or that one.
Yeah, but it's the same as that one, isn't it? But just swap the x and y.
Yeah, well, if you swap the x and y, then that's now the inverse function. Yeah? So you can sketch the inverse function. You could sketch the inverse if you want, but that's the problem. Like sometimes the graphs are even worse if you find the inverse. But the easiest one is start off with what they give you, because what they give you is going to be the easiest thing to do. You can find the domain and range from that. That takes care of the inverse issue.
Wait, so how did you know that it was only the positive value for y?
Because the domain of f is heading towards the infinity side, which is positive. So in a quadratic sense, that for it to have an inverse, it has to be from the center to the right. So if it's from the center to the right, that means it's a positive number. True?
But isn't it like 7 days? Isn't it from being just negative 2?
Which is negative 2.
So isn't that negative?
Yes, the x value is negative, but that means the range then would be from negative 2.
So would the domain here be 0 to...
So if it's going to infinity, it's the top side.
The range be 0 to...
Yeah.
All the values increasing from 1 to each.
Yes, and because it's got a square root function, you only got the top and the bottom. See what I mean? So if it's the top, top's the only one that's going to infinity. So I didn't really care where this started. It could start negative anything I want, but all I cared about was it going in the positive direction? So was it going to the negative direction? See, if it was the other way around, it said negative infinity up to B. I don't care what B is. I just know that means the range now has to be negative infinity all the way up to B. So that has to be
It's still infinity.
Yes, but remember the domain is the range of the inverse. Yeah, the first problem.
That's the range.
This is the inverse, and from here, when I sketch this graph, we have either negative 2 plus x plus 4. You have that graph, which is a positive root. Positive root is like this. And, or you have negative 2 minus root of x plus 4 equals y. That's a negative graph. So I just don't know which one it is. But since I know that the range of the inverse had to be a positive one, because it's heading in the infinity, which one of these will head to infinity had to be this one.
Is that range? This thing is all just the range of that value.
Yeah, but we found it.
Because you got to infinity, out of these two graphs, the only one that's going to go to infinity is the positive. That's why I'm taking the positive as opposed to the negative.
Yeah, so you basically just look at all you have.
And that's key. That's very key. So key because most students don't look at that. They just get to the graph and carry on. That's why it's an issue. All right. Here we go. Next problem. Oh, I didn't bring my pencil case. Oh, here it is. Next one. Actually, we'll come back to this one. Actually, no, it is this one. All right, we have to do it. All right. All right. Here we go. Lie down. Stop talking. All right, so we've done the first one. It was completing the square when you have two variables, and then check the domain whether it is, because that's going to change the range of the inverse. Okay, those are the two things I wanted to point out. Number two is that for those who aren't used to looking at something like this, so you got x plus 4 over x plus 1, same drill again. If you put the y's and x, if you do the reflection, the problem is you're going to have two y values again. Now, there's a lot of ways to do this, by the way. So I'm going to show you just a few of them, and you're going to figure out which one you like and the way that you're going to do it. Okay, so if I asked you to find the inverse function, and we went with the idea that, that this is y equals to x plus 4 over x plus 1, then doing the inverse, you swap the x and y's, and they now become this, right? And there are tons of problems on this idea in your exam. If you do the checkpoints, these will come up often. Now, it's up to you how you want to do this. Sometimes you could get A, B's and whatnot, and they're all pronumerals. Then you have to figure out, well, how are you going to rearrange it? Now, there's a lot of ways. Here, you can actually read it as it is. Y plus 4, this symbol means divide. Divide by y plus 1. The only one technique you learned last year with polynomial division was to divide one expression over another expression. So one technique is that you could use polynomial division, or for those who are more familiar, cubic division. Okay? That would have been the one. So if you did y plus 4, you're saying how many y plus 1s fit into y plus 4? That's essentially what you're asking. So if you really think about it, back to polynomial division, how many y's fit into y? We know it's 1. So we say, all right, from last year we said if it goes once, then one group of y plus 1 will give me a remainder of 4 minus 1, which is 3. So how do you write your answers again? When you divide it, this is equal to 1 whole with an extra 3 remainder of y plus 1. Now, for those who are confused by this technique that I just wrote, go back and revise polynomial division. Normally, I actually go through the steps in year 11, and I show you a comparison where you do 3 divided by 2. So if you do 3 divided by 2, you get 1 whole and a remainder of 1, and you would write 1 plus 1 out of 2. That's why we know 3 divided by 2 is 1.5, right? It's the same technique. And if you're confused by that, then you got to go back and revise polynomial divisions from last year. Okay? Now, that's one way of doing it. That's one way of doing it. So that answers this question. If they want you to find A, B, and C, well, I split it up already. I've got 1 whole and you've got A's 3, C's 1, and B's 1. Okay, so you can do it that way. Alternatively, some students from Spec, they will rearrange the numerator so that it splits these two into one whole. So how would you rearrange it? You could do this. You could say it's x plus, now if you need 4 in the numerator, well you can do this. You can say plus 1 plus 3. There's nothing wrong with that. True? There's absolutely nothing wrong with saying 1 plus 3 is 4. I'm okay with doing that. Now with fractions, they all have the same denominator, and what you could do is you can split it up and say, well, it's x plus 1 over x plus 1 plus 3 over x plus 1. True? It's like fractions. I can separate it. Yeah? And then therefore, x plus 1 divided by x plus 1 is one whole, and I still got that 3 in the numerator over x plus 1. So that's fractions. So that's what some special students do. Sometimes it works, sometimes it gets harder, especially when you have 2x and whatnot. I always recommend to do the division, because you're always going to get your answer regardless. But if you're quick with these kind of problem solving, then do it that way, right? The third option, so there are a lot of options here. The third option, depending on what problem you get, I sometimes use the third option. The way I taught my year 8s and even my year 10s right now, if you don't like fractions, get rid of it. And one of the ways to get rid of fractions is do the inverse operation. Now think about it. If I gave you hypothetical x over 3 equals 12. Oh, sorry, 4. Let's do 4. Ah, that looks ugly. 4. How do you get rid of 3 again? It's x divided by 3. What did you learn back in year 7? What do you have to do to get rid of divide 3? Multiply. It's no different with this problem. If you don't like the divide x plus 1, then times it. There's nothing wrong. As long as you do it to both sides, it's okay. So here, what we did was we said left-hand side times 3, right-hand side times 3. 3 divided by 3 cancels out to be 1. So 1x equals to 4 times 3 is 12. That's what you did in year 8. Yeah, and I teach that all the way to year 10. It's the same drill with this one. If you don't like it, you can multiply. Whoops. Where'd it go? Oh, I've lost it. Is it this one? Oh, there it is. You can multiply both sides, in this case, by y plus 1. You get y plus 1 multiplied to x equals to y plus 4. Okay, expand the brackets, and you get xy plus x equals to y plus 4. And this is great because now you can move the y across and factorize it together. So if I minus y on both sides now, so minus y, these cancel out. And you minus the x here and minus the x there, so I'm just moving it across. X here, minus x on both sides. These two cancel out. And what am I left with? I now have xy minus y is equal to 4 take away x. See what I'm doing?
Next level.
Now why is that nice? Because if they both have a common factor of y, factorize it. If you take it out, it becomes x minus 1, 4 minus x, and you got y on your own. This is times. So opposite of times is divide. Divide both sides by x minus 1, and you're done. So here we've got y equals 4 minus x. Sometimes you will need to use this technique, because depending on what fraction they give you, like if they gave you a lot of things on the bottom like ax squared plus bx plus c, then you're screwed. It'll be difficult, but what you could do is do what I just showed you, and you can still isolate y by itself. Okay, so it's either way, you choose which one you want to do, but it's the same technique. Okay, so there were 3 of them there. 1 is polynomial division. 2 is problem solve very quickly. There's no technique to that. It's whether you can figure it out. Or number 3, get rid of the denominator. So whichever one that you prefer, I would suggest polynomial division because that's the only one that's methodical. And you teach 1, 2, 3, 4, and you do that for every one of them, and it works every time, right?
Yeah.
The others is sort of you got to be flexible. But I'm teaching you all 3 techniques to figure out how you would do that. Okay? You can copy the notes if you wish.
How did you get a negative?
Where? Which one?
You know how you did that method that you talked about now? You jumped from the last line. No, the top x y minus y.
X, y minus y, yep.
And then became a negative, and then there you've got a positive.
That's a minus.
Yeah, but down. Keep going down. Yeah, that one. Down.
Okay, this was, sorry, this is from here.
Alright.
So I times this on both sides. So if you don't want the denominator, multiply both sides by the denominator. So I times this side by y plus 1, it cancels out. And I times this side by y plus 1.
Yeah.
Yeah? And so times in this side by y plus 1 will be x times y plus 1.
But how did you get a negative? That's right.
So
How did you get the minus? Because it was positive.
because I expanded it, and then I moved the x across, and then I moved the y across.
Actually, you know what's my brother?
So when I move the y across, it should be negative now.
It's not like that.
Yep.
I just like to
All right, Ivana?
my bio notes.
Yep.
As your final answer,
Yeah.
because you wrote y is equal to x over x negative 1. Can I write 3 over x negative 1 negative 1? Like the a over x plus x.
Oh yeah, that one. You're meant to. You're meant to do that.
Oh, I meant to.
Yeah, because that question asks you to do that. I'm just saying, in general, if you want to isolate y, there were 3 ways to do it. Yeah.
I don't know what you're saying. I don't know.
The best way, I reckon. It's the most consistent, but not everyone knows that or likes that. There's a 2x, like for that one.
Do you want to
I haven't yet thought of it, but I want to teach that other property. I'll come back to the 2x, and then I might teach it to the class, yeah? All right, here we go. Now, here's the other property. So I taught you, listening, shh, shh. We're short on time, listening. Here we go. So I taught you how to complete the square when you have 2 variables. I've taught you when you have 2 variables when it's a fraction. The other thing that I talked about was I told you to write down the reflection. I told you to write, wherever it is, I must have deleted it. I said the third property is the reflection in y equals x, and I said that was very important because in your exam, in that particular question, they also asked you to sketch both functions on the one set of axes, right? When you sketch these two, it's going to look like this. I'll show you in the next page. When you finally sketch them, this is what it looks like. You get 2 of them. Both, one's a function and one's the inverse. Then your job in the exam or SAC, they will ask you to find the intersection. Naturally, how do you find the intersection again? What do you normally do? How do you find intersections of 2 graphs?
make them equal to each other?
You let them equal to each other. And here's the problem. Depending on what graphs you get, they're not going to give you numbers. In the exams, they will give you pronumerals or sort of like parameters. They'll say x minus a, minus b, and then they'll have something up here that might be valuable, right? But then if you equate that, it becomes problematic because not only do you have 2 fractions on each side, you now got parameters to work with, and it's a lot of work. It's a lot of work, and that happened last year where the students were writing a lot of work, and there was only this much space to do the work. And everyone's complaining about it because everyone wasn't paying attention to the third property. The third property was saying it's a reflection in y equals x. So what does that mean? That basically means that the line of reflection is right here. That's where they're reflecting. So the only time when they cross, it means they're crossing right at y equals x. So what that means is, yes, you're all doing this. You're doing f of x is equal to the inverse. But not all the time that's easy. Most times it's actually hard, especially in the exam. The easiest way to find the intersection is when does it equal to the reflection line, because that's where they cross. The only way that they're going to have the same point is that's where the reflection line is. This is your y equals x line. I'm going to just draw it here. This has to be the reflection line. If you tilt your head, it's symmetrical. The only time they're going to cross is right at y equals x. So that means both of these equations must equal to the line y equals x as well. That's why that's the third property. The third property is that it's reflected on y equals x. Therefore, x is equal to the inverse, and it's also equal to the function. That is much easier to solve. If I put x here now, if I said 3 over x plus 1 equals x, it's so much easier to solve than trying to do this equals that. Okay, and that's what I've done in this slide here, where I let it equal to x, and you can see my technique here. How do you get rid of fractions? Multiply them all by the denominator, and that's what I've done, and it makes it easier to solve. But if you don't do it that way, and you try to equate these two, 1, you might go in a circle. 2, you might not get a chance. I'll tell you when you get a circle. What's an inverse of an exponential? Logarithms. You put those 2 in together, and you try to remove the log, you do an exponential, and then the other side is exponential log, and it goes back and forth. Okay, so if you get a log and an exponential, and you try to equate those 2, it's not going to work. The best way to do it is let equals x. So write that somewhere in your notes because it will come up, if inverses come up in exam 1 or exam 2, that's a common one. Okay, so there's only 3 properties. So I went through the 3 properties with you. You have intersection when you're sketching. You have domain of f is the range of inverse. A lot of students forget about the domain and not checking that. Okay, And then when you have two y variables, it's either complete the square or polynomial division. It's one of those two. Those are my tips for 1F. Okay, so if you haven't done that exercise, do it. It's the last few that is important. If you're doing the first few, it just gets you the feel of it. But do the last few questions. That's where you're learning. Okay, that's where you're learning how to apply that into a second examinable question. Okay, so I'll leave it there. I think that was all I needed to cover. And do we have? No, we don't have enough time. So double session next. I will teach you an overall functions, get you to really think about x squared, x cubed, x4, x10, negatives and fractions. Because once you get that, you don't need a calculator to sketch it anymore. You can visualize it.
How do you want you tomorrow?
I don't have you guys tomorrow. I've got Thursday double session.
Oh,
Yeah.
Can you go back to the slide, that one when you were doing the form where the xy?
Yep. Just move it back. This one? Yep. My working out's all over the place. So tell me where you're up to. I went from here and I moved up there. Yeah. So I went from here and I moved there. So right.
Why wouldn't that work? Like, you know how you're minusing x's and y's?
Yeah, I minus x on both sides, so it's all minus x on this side. And here I've got a y, so I minus y on both sides.
Why couldn't you just keep x, y, x? They both got like the x's are on.
Yeah, because my goal is to find the inverse function. So I need the y as a subject. Every time you sketch a function, y is on the outside, and you always have the x's in the equation, not the other way around. Yeah. Because we want to find the y as a subject. That's why. Wait, let me stop the video so we don't get all these random questions in the video.